Welcome to another video by class for SM1 Group English. I am your host, Trisha May Awi, and let us get started. Today, we have our guest from the BSed English section for SE1 to join us in another exciting activity involving a very easy fundamental concept involving abstract algebra, the concept of modular arithmetic. Please welcome our participants for this afternoon. We have Amethyst, Kat, Ria, that's for team 1. And for team 2 we have Gopal, Jerome, and Micah. Kids, are you ready to crack some codes today? Yes! To start, let us call our game master for this afternoon. We have Mr. Toby R. Toledo.
Okay, so today we will be cracking codes. Now, do you know codes, teams? So, do you know cryptography? So, cryptography is the art of coding or encrypting certain messages. For example, if we have a certain message called I love you, we can encrypt that so that no one can understand that besides the one you're sending it to, because he knows how to decrypt it. Okay. So our game for today is a simple application of an abstract algebra fundamental concept called modular arithmetic. But we will not delve with that, but with a simple game only where you will be decrypting messages. So the mechanics will be, I will give both teams the same coded message. Okay? Then you will attempt to find the hidden message by doing this. Okay, you will write all the succeeding letters of the coded letter under it. Do the same for all the letters until you find a sensible message. For example, if I give you a message F-I-L-S-B-I-O, then you will have to write all the succeeding letters of F under it, I, the succeeding letters of I, and so on, until you reach a message that makes sense. Okay. Do you understand instruction? I know you understand instruction. Okay, so F-I-L-S-B-I-O means I love LR. So this is the cipher text, and this is what we call the plain text. Okay, your goal is to find the plain text. Are you ready?
Yes!
Okay, the first team to find the correct message will be awarded a point. So we will only have 3 rounds. So are you ready?
Yes!
You're ready. So our first message will be FIFHBVLR star. Okay, our players are very seriously answering their encrypted messages.
I like you! I like you!
Okay, so the first team. Okay, so. Okay, first team, please place your answer on the board. Okay, place your answer on the board. Okay. So place it like here. So we cannot see it now, but the plain text is I like you. So team 1 wins the first round. For team 2, please space also your outfit. Okay. Let's proceed to our second round. Okay? The second message is SQCNGYL, your time starts now. Got it first with the plain text is Yusebian. That is correct. So that is Yusebian. So team 2, please paste your output now at blue 4. Okay. We only have one round left. So I think we have a clear winner, but we will just finish the game. Okay. So our third message will be, this is a very familiar book author. That is QRCNFCLIGLE. Your time starts now. Okay, what is your answer, team 1? Okay, the correct answer is Stephen King. So that is correct. Clap your hands for team 1. But we will still go for team 2. So after 3 rounds of competition, in the first round, team 1 got it. The answer is I like you. Then the second round it is Yusebian, still team 1. And the third round it is Stephen King. So that is still team 1. So after 3 rounds of competition, our winner is team 1. Team 1. Congratulations team 1, and I hope that you had fun playing our game this afternoon. But before we let you go, let us first learn what is the connection of our activity today with the concept of modular arithmetic. The activity we did this afternoon was some of the many applications of abstract algebra and one of its fundamental concepts called modular arithmetic. We did cryptography or cryptology. In doing cryptology, we must start with an uncoded text or with what we call a plain text, such as love. That plain text is what we're going to encrypt. But first, we must assign each letter of the alphabet of numbers 1 to 0. So, letter A will be assigned to 1 and Z will be assigned to 0. So, B will be assigned to 2, C is to 3, D is to 4, and so on. We can encrypt the message by using the congruence. C is congruent to P plus M mod 26. Why 26? Because that is the number of the letters in the English alphabet. Determine how large the M we will use. So for example, we use an M called 6. So if we use 6, which means we will shift a letter 6 places from its original position into the new letter. So for example, if we have A, then we will shift it 6 places. So it will go to the 7th letter, which is A, B, C, D, E, F, G. So A now will then be coded to G. So for example, we have L. So the cipher character for L will be L. What is the code for L? So that's A, B, C, D, E, F, G, H, I, J, K, L. So that is 12. So we have 12. That is what we'll put for P, because that represents the plain character. Plus M, which is 6. Mod 26. So we just add 12 and 6. That will be 18. Mod 26. So 18 modulo 26 just represents the remainder when we divide 18 by 26. So the remainder will be, of course, 18. So the new character will be the 18th letter. So that will be L, M, N, O, P, Q, R. So that will be the character R. So L will now be encrypted as R. So how do we decrypt a message? So we'll go back to the letter R. So the letter R corresponds to 18. So 18, we will now supply it to our next congruence, which is P, which is plain text, is congruent to, that is P plus N modulo 26. So the N now will now be represented by 26 minus M. So what is our M previously? So that will be 6. So our N will be 20. So we will supply N with 20. So C is obviously 18 plus 20 modulo 26.
3, 2, 1, go.
Okay. So P is now congruent to 18 plus 20 mod 26. So when we add that one, that will become 38 mod 26. So as I've said moments ago, that will be the remainder when 38 is divided by 26. So that is obviously 12. So P is now 12. We must observe that we have come back to the number 12, which represents L. So we have successfully encrypted and then decrypted a certain message. So that is the function of cryptography. What we did earlier in our activity was just to enumerate the letters consecutively in order for us to get the message. For example, if we want to get the message behind X, O, R, M, we must list all of the letters underneath the given encrypted word in order for us to get the plain text. So that will be O, P, Q, R, S, T, M, N, O, until we actually get a sensible word at the bottom. But that takes so much time, especially when we choose an N that is too large. So the modular arithmetic operation is more convenient in using that. So okay, participants, after the game, what did you realize about cryptography? Is it fun or not? Miss Antis? Okay, Miss Amethyst finds it fun. How about our TCS Senator, Mr. Geraldo Maclawan? How do you think of the game?
That's quite motivation.
It's quite motivating or not so? Okay, it's really motivating. How about Miss Maika? Okay. And now finally, we'll ask for the opinion of Miss Maria Umbrosa. What do you think about the activity about this abstract algebra?
Yeah, it was challenging. Yeah, it cracks
It racks the mind of the players. So based on the testimonies by our participants, it is really proven that mathematics is not just about numbers. It also deals about different words and different aspects of our life. Just like in cryptography, it can also be useful in wars. As they say, not only bullets win wars, but also mathematics. So thank you, participants. Thanks for joining us today in our game, and hope to see you soon.
You have learned something today. See you again in another video about the wonders of abstract algebra. This has been Trisha May Awi. Thank you and goodbye!